Chapter 10. In this chapter, we're going to be covering right triangle trigonometry as well as going over the trigonometric ratios. Let's do a review of angles and triangles. The point of intersection between two lines is called the vertex. This is the vertex. And the space between the lines is called the angle. An angle can be described in one of three ways. Either ABC, A, B, C, with C being at the vertex. Vertex letter only, so in this case that would be V, or a letter or number placed inside the angle. The basic unit of measurement of an angle is a degree, and the degree can be further divided into units known as minutes and seconds. These units aren't related to time. Here are the conversions. 1 degree equals 60 minutes. 1 minute equals 60 seconds. For an angle of 62 degrees, 12 minutes, 37 seconds, we would write it as 62 with the degree sign, 12 with the minute sign, and 37 with the second sign. And most of the work you do will require you to only calculate it to the nearest degree. There are 4 categories of angles: obtuse, right, acute, and straight. So for an acute angle, it's a sharp angle. It's less than 90 degrees. An obtuse angle is greater than 90 degrees. A right angle, of course, has 90-degree angle. And a straight angle is a straight line. Converting angle units. Sometimes in your work, you'll need to convert an angle measured in decimal degrees to its equivalent measure in degrees and minutes. And again, let's reference the conversion. 60 minutes is 1 degree and 60 seconds is 1 minute. Let's convert 17.5 degrees to degrees and minutes. There are 2 steps. Step 1, we're going to write as the sum of a whole and a fraction. So we're going to write 17.5 degrees as 17 degrees plus a half a degree. Now we're going to use the conversion between degrees and minutes to convert the fraction part. So 1/2 degrees times 60 minutes to 1 degree equals 30 minutes. Just multiply it out, 60 divided by 2. Now add the whole and the converted fractions together. So 17.5 degrees equals 17 degrees, 30 minutes. Convert 24 1/3 degrees to degrees and minutes. Turn off your video, try it for yourself, and then we'll go over the answer. Converting 24 1/3 degrees to degrees and minutes. First thing we're going to do is we're going to separate the whole and the fraction part and write it as 24 degrees plus 1/3 degrees. Now we're going to convert the 1/3 degrees to minutes by using the conversion. 60 minutes to 1 degree. 60 over 3 equals 20 minutes. And now we're going to recombine 24 degrees and 20 minutes. You will also need to be able to convert from degrees and minutes to decimal. Let's convert 72 degrees 60 minutes to decimal. Again, there are 2 steps. The first step is to write the angle as the sum, 72 degrees plus 6 minutes. Step 2, we're going to use the conversion between minutes and degrees to convert 6 minutes times 1 degree to 60 minutes. 6 divided by 60 equals 0.1 degrees. And then we're going to add the whole and decimal parts back together. And we get 72.1 degrees. Right triangles. Trig is basically triangles. We're going to begin with just right triangles, and you know a right triangle is one that contains a right angle. In any triangle, whether it's a right triangle or not, the sum of all 3 angles equals 180 degrees. But in a right triangle, the 3 sides of a triangle have very specific names. The side opposite the right angle is called the hypotenuse, and the other 2 are called the legs. The Pythagorean theorem is an equation relating the lengths of the sides of any right triangle. C squared equals A squared plus B squared, where C is the hypotenuse, the side opposite the right angle, And A and B are the other two sides, and they can be in any order. It doesn't matter. But the hypotenuse always has to be the side opposite the right angle. Let's do an example and find the missing value for this triangle, which happens to be the hypotenuse, so side C. The Pythagorean theorem would be set up as C squared equals 20 squared plus 21 squared. That equals 441 plus 400, which equals 881. So we have C squared equals 881. Now, C has a square, so in order to find C, we have to take the square root. So taking the square root of C squared gives us C. Taking the square root of 881 gives us 29. So we've solved for C, and C equals 29. So let's find the missing leg for this triangle. Turn off your video, try it for yourself. Note it's one of the non-hypotenuse legs, and then we'll go over the answer on the next page. Again, using the Pythagorean theorem, this time we have C in one of the legs, but we don't have the other leg. We're going to call the leg we're looking for leg B. The Pythagorean theorem would be 18.1 squared equals 6.5 squared plus the unknown, B squared. 327.61 equals 42.25 plus B squared. Now we just have an algebra problem with an unknown. So we're going to subtract 42.25 from both sides so we can isolate the unknown B squared. 327.61 minus 42.25 equals 42.25 plus B squared minus 42.25. And that gives us B squared equals 285.36. To solve for B, we have to take the square root of both sides. We take the square root of 285.36 and we get 16.9. So we have a solution. B equals 16.9.